There are two ways that we could use the Pythagorean theorem. One of them is to find a missing side length in a right triangle, but we have to know that that triangle is right. The other way that we can use the Pythagorean theorem is if we know all three side lengths of a triangle and we want to determine whether that triangle is right. If we plug those numbers into the Pythagorean theorem and it is true, then we have proved that it must be a right triangle. So that is called the converse of the Pythagorean theorem, basically working backwards to prove that a triangle is right. So we're going to show how to do that with these two triangles. Let's look at this first triangle on the left. Now in this case we know that our C, our hypotenuse, must be the longest side. Our largest value is 10. So that means my A and my B are going to be 5 and my C is 10. So let's plug that in. I have A squared plus B squared equals C squared. Now 5 squared means 5 times 5. I've got 25. Again, plus 25 equals 10 times 10 is 100. Now I know right now that 25 plus 25 is definitely not equal to 100. It actually equals 50. So I can tell right now there is no way that this triangle is a right triangle. So now let's try the same thing with the triangle on the right. So again, we want to make sure that our hypotenuse, our longest side in the triangle, so my greatest value is 5, that is what's going to get plugged in for C. So then I could use 3 and 4 for my A and B, and then my hypotenuse is 5. So I have A squared plus B squared equals C squared. 3 squared means 3 times 3 is 9. 4 squared is going to be 16, and 5 squared is 25. Now if I add 9 plus 16, I do get 25. So my statement is true, which means yes, this triangle on the right is a right triangle.